Engineering Mechanics Statics, Lecture 8. This is Chapter 3, Static of Rigid Body. So we have 4 components in this chapter. The first one is moment, and then equivalent system, equilibrium of rigid body, and structural analysis. For the first one, we are going to learn about moment. There are 3 parts in this chapter. In this part, which is moment of force about specific axis, and moment of couple. So for this lecture, we are going to see this part, moment of force. This is the objective. The first one is to understand and define moment, and the second one to determine moment of a force in 2D and 3D cases. In this lecture, we are going to learn about moment. Okay, so first thing, we need to know the difference between force and moment. Let's look at the first picture here. Okay. If we have 10 kg of force and a steel rod like this, which is attached on the ground here. So in this position, we have only the effect of force here. Okay. And then if we move the force of 10 kg here to the tip of the steel rod in this position, so we have from here we have a distance d here, and then the force downward here. Okay. This situation will cause the effect of the steel rod, and the force is tend to rotate. Okay. This effect, we call it as a moment. Okay. When there is we call it a line of action. D is a line of action, and the force, and it tend to rotate, so we call this is a moment, which is a tendency to rotate. Okay, so it's either in a clockwise direction, or if the force is upward, it will become counterclockwise. Okay, if we take out this part, okay, become like, so we can redraw it to become like this. So when the line of action and the force is tend to rotate, and the line of action and the force is in perpendicular position, which is 90 degree. So this look like that there is a pin here. Okay, the pin here is act as the center of the rotation. Okay, so moment is a tendency to rotate, where moment is equal to m is equal to the distance d, or line of actions, multiplied with the force. That is the definition of moment. So the moment is d multiplied with f. So this is the direction of force. How about the direction of moment? The direction of moment is going out from the rotation. This is the direction of the moment. Or you can use the right hand rule. Okay. So, or other example is like this. So this is your line of action. You try to unscrew the using this spanner. So you apply force here. So the spanner will coming out. This is the direction of moment. Okay. So simply we can draw the free body diagrams like this. This is the line of action. This is a force, and this system is tend to rotate, and so this is the effect of the moment about and at O axis. Okay, that one, for one case that F is downward here like this, 10 kg is downward like this, or we would say that the force is act in the same axis as y axis. If let's say the force is act like this, it is not neither in a y axis or x axis. So how are we going to calculate the moment? It is not simply we calculate that moment is equal to F multiplied with D. So there's some step you need to do. Okay, so you need to break the F into the component of X and Y. Okay, so if you look at this, like this case, your F is equal to Fy. This is because it is at the axis of Y. So this is only one force, which is in the Y axis, but in the X axis there is no force, so Fs is equal to 0. So you can simply find the moment m1 is equal to d multiplied with Fy, which is Fy is equal to F. Because Fx has no force, so moment in this direction is equal to 0. But it is not like this case. So in this case, there is a force in both component of X and Y. Okay. So if you look at this, so you need to so you actually need to break the F into the component of Fx and Fy. So when you do this, you will come up with this component. Okay. So line of action for Fx is this one, and the force is this one. Remember, the line of action and the Fx must be in a 90 degree or in a perpendicular position for moment cases. Okay, so this one is m1 equal to d1 multiplied with Fx. So for Fy component, this is the line of action and it is a force. So m2 is equal to d2 multiplied with Fy. So when you total up the moment, so you will get the moment for this system. Okay. So but remember, before you multiply, so Fx must be equal to F cos theta. F cos theta. Okay. And Fy is F sin theta. Now let's do some example here. Given that a 400 Newton force is applied to the frame and theta is equal to 20 degree, so you are given force 400 here and theta is 20 degree, and find the moment of the force at A. About this point, you need to find the moment of the system. Okay. So the first step, you need to resolve the force along X and Y axis. This force you need to resolve into X and Y axis, and then determine the MA using scalar analysis. So if you resolve the F in a Y component, so let's set the direction, the upward direction is positive. So when it is downward, the force is negative 400. Your theta is 20 degree here, so when it is downward, it is sine 20. Okay. Fy is sine 20, so which means that Fy is equal to negative 100 sine 20 degree Newton. Okay, and then for the component of fx here, so when fx is in this direction, so fx over f is equal to cos 20. Okay, so f is 400 and then multiply with cos 20, and the direction we set the direction, the right direction is positive, so because it is in the left direction, so it's become negative. Okay, so to find the moment for fx here, you multiply with the line of action of fx. So fx in the direction, so line of action, you must remember it is perpendicular. So line of action for fx is this one, which is 2 meter. So multiply with 2, then plus the moment for component of fy. The fy is this one, 400 sine 20 degree. So fy, component of fy is downward like this here. So the line of action perpendicular of the force is this in this part. Okay, this is along 3 meter from the point A, because we want to find the moment of about point A. So multiply with 3. So the total of this moment is equal to 1160 Newton meter.